Welcome, and in this set of notes, I'm going to go over an introduction to exponential functions with you guys. To start things off, an exponential function is a function that is written in the form y equals a times b to the x. Notice that our variable x, it appears as an exponent in our equation. This is the first time you've seen x as an exponent. Previously, x has always been a variable in the equation, whether it was linear or quadratic. Now we're getting into exponential functions. If all the y values of a function have a common ratio, then the function is exponential. A common ratio is what you must multiply each term by to get the next term. So if you look at example number 1 here, we're looking at just the y columns, okay? What would we multiply 0.5 by to get 3? What would you multiply 6 by to get 18? What would I multiply 18 by to get 108? Okay, now one way you could look at doing this is just take the next term divided by the previous term. So if you took 3 divided by 0.5, that would tell you exactly what you multiplied 0.5 by to get 3. In this case, it would be 6. So we can test that out with all of these. 3 times 6 gives you 18. And then 18 times 6 would give you 108. And so this would prove that in number 1, the table, our common ratio here is 6. Before I get into writing the equation, let's go down here and understand what the a and the b mean in our equation, our formula. Your a value is your y-intercept. Okay, remember a y-intercept is always going to be the order pair 0 and then your y value. Okay, so x is always going to be 0. This is what we also call the initial value. So this is our initial value. So it's our starting value. Your b is what we've already figured out. This is your common ratio. I like to think of it as y2 divided by y1. I think that's an easy way to figure it out anytime you're dealing with exponential functions. So we've already identified our b. Okay, this is going to be our b. 6 is our b. So I'm just going to write b equals 6. Okay, so we still need to identify our a value, or our initial value. So to look at that, we're going to look down our x column and find where x is 0, which is right here. And so that means 0, 3 is our y-intercept. So that means our a value then is 3. Remember, it's the y value, not the x value. Therefore, our equation then is y equals 3, parenthesis, 6 to the x. Your exponent will always be x whenever you're writing these out. To draw your graph, the main thing that I would be looking for is your y-intercept. Okay. I can't really graph all the points on here. I just don't have enough space. But my graph would look something like this. Okay. Notice that the line approaches our x-axis, but it never reaches it. This is called an asymptote. I know, asymptote's a funny word. So an asymptote is going to be this imaginary line that we're going to approach, but we're never going to reach it. Okay. Since our asymptote is the x-axis, that would be the line y equals 0. Because it's a horizontal line. The domain for our graph is always going to be all real numbers. And you can write it using the symbol. You can write it using inequalities. Or you can write it out in words. Okay. Since our graph never reaches the line y equals 0, which is the x-axis, and that's our asymptote, then our range for the graph is just going to be all of our y's greater than 0. Notice it's not greater than or equal to. Because that's an asymptote and we can't actually reach it, we can't touch it, then that means we cannot include the equal to here with our inequality.